as I want to welcome you to revisionug.com. Please, I urge you to subscribe, share and follow. Please click on the link below to get the latest updates and well organized notes. Alright, let us get started. In the previous lessons we looked at inequalities, introduction, solving them and representing them on number line. So in this lesson we are going to look at solving quadratic inequalities and represent them on a number line. So let us get started. Our first example states x squared plus 9 is greater than 6x. So from our previous lessons we looked at quadratic equations and how to solve quadratic equations. From those lessons we looked at solving quadratic equations using factor method. So here we are going to use the factor method, but before doing that we are going to first make this one to write it in terms of a quadratic. Remember, a quadratic equation it is less, greater or equal to a 0. So we need to bring this 6 this way so that it is greater than a 0. So it is x squared, then minus 6x, then plus 9 is greater than a 0. Now from this quadratic equation we are having a product. There is always what we call a sum and the product. So when we look at negative 6 is our sum, then a product it is a 9. So here it is telling us that there are two numbers. When you multiply them they give you a 9, and when you add them they give you a 6. So those factors are 3 and 3, but if there are 3 positives, they are if we add them they are going to give us positive 6. So if we multiply them they are going to give us a positive 9. So but we need to get them when they are giving us, when we add them they are giving us a negative. So negative 3, negative 3. So negative 3 times negative 3 we get positive 9, negative 3 plus negative 3 we get a negative 6. Therefore we expand our equation. So x squared, so these factors we are going to put them where the sum is. So minus 3 in terms of x minus 3 in terms of x plus a 9 is greater than 0. So we are going to divide our equation into two, this one and also this. So we are having x squared minus 3x into brackets, then minus 3x plus a 9 is greater than a 0. So we are going to factorize our brackets here. So we have x out into x minus a 3, then minus, then what is common to this bracket is a 3, then it is x. So to keep the signs constant, so we have to change this positive to a negative, so that when we open negative times negative we get a positive, then 3 is greater than a 0. So we are now having one bracket having x minus 3, then another is going to be x with the negative 3 also. So that will be x minus 3, so is greater than a 0. Now so when x minus 3 is equal to 0, so we are going to have x is equal to a 3, or when x is minus 3 is equal to 0, it's also going to give us x equaling to what? To a 3. So to represent this one on a number line, we are having one boundary point, that is a positive what? A positive 3. So when we come to the extreme left it is going to be negative infinity, extreme right is going to be negative positive infinity. Now to get the solution set we are going to have either a 3, but now this one is not saying less or equal to, so that one will not work. So we are going to test our testing numbers that are beyond a 3, then these numbers that are behind 3, towards the positive, towards the negative. So from here we are going to choose a 0, and we are going to satisfy it to put it here, and we see whether it can satisfy our inequality. So let us test that one. So we have x minus 3 into brackets x minus 3 greater than a 0. So if x is a 0, so this is 0, we put here 0 minus 3, then into 0 minus 3 is greater than 0. So what are we having? We are having now this is negative 3 into negative 3 greater than 0. So negative times negative 3 get a 9. Is 9 greater than 0? Right. So meaning that this one can work for us. When we go this way we can satisfy. So our first region which can satisfy our quadratic region, inequality, it is saying x must be And when you look at these numbers that are going towards left of 3, they are less, so x must be less than a 3. So now let us also test if now x is greater than a 3. So we choose, we pick any number that is greater than a 3 towards the right, whereby towards the right we are having the positive symbols, I mean the positive digits. Therefore, if we suppose we choose a 5, so 5 minus 3 into 5 minus 3 is greater than 0. So what is this one? This is 2 into 2 is greater than 0. So 4 is greater than a 0. Therefore, yes, this is also right. Then we are also having this one. Another solution inequality is now saying x is also greater than a 3. So x is either is greater than is less than a 3, is less than a 3, or x is greater than a 3. So these ones, they are going to give us the inequality digits that are satisfying our quadratic equation. So on a number line, it's going to appear like this. Alright, so let us look at another example. This one is saying x squared minus x is greater or equal to 12. Remember, it is a quadratic, so we have to write this one in form of quadratic. So we shall now get x squared minus x, then minus, because when we remove this one from this way, it's a positive, so when it crosses here, it becomes minus 12 is greater or equal to a 0. So our sum and product, the sum is -1, then the product is this is -1, then the product is -12. So two numbers, when we multiply them, they give us -12, and we add them, they give us -1. So those factors are -4 and a 3. Then we substitute in here, that is x squared minus 4x plus 3x minus 12 is greater or equal to a 0. So we are having x squared minus 4x, then plus this portion here, which is 3x minus 12 is greater or equal to a 0. Then here we are going to factorize, then this is x into x minus, what is this one, minus a 4, then plus what is common here, it is a 3 out, then x minus what, a 4 is greater or equal to a 0. So this one is going to go with this, then this is x plus a 3, and we choose one bracket out of the two, that is x minus 4 is greater or equal to a 0. So now our boundary points, our BP, the boundary points are from here. We are going to have, if x is equal to 0, now x plus 3, if suppose it's equal to 0, so x is equal to -3, or if x minus 4 is equal to 0, then x is equal to a 4. So our boundary points are -3 and a 4. So we draw our number line. Oh gosh, let me make it clear. So we draw our number line, so we are having -3 and a 4. So if we have now three regions, this is a number line, now this is going to -infinity, and now this is going to positive infinity. So we have region A, region B, and region C. So we have to test and see which region is going to satisfy our quadratic equation, or which region is having the solution set, or the digits, or the integrals that are satisfying our quadratic link. Remember, it was x plus 3 into x minus 4 must be greater or equal to a 0. So let us start. Remember, it was less or equal to, so -3 is inclusive, and also -4 is going to be inclusive. Now let us test if we move towards -3. So towards the negative, let us choose -2. So -2 plus 3 into -2 minus 4 is greater or equal to 0. So what is this one? This one is going to be 1 into -2 -4, that is -6 is greater or equal to 0. So -6 is greater or equal to 0. Is it right? Is -6 greater than 0? Is it greater or less? It is less. Therefore, this region is not going to be applied, so it is not satisfying. So from this area we are not getting any digit which is satisfying the inequality. Then let us look at this one between -3 and 4. Let us choose one digit. I can choose a 0. Then if x is a 0, so it will be 0 plus 3 into now 0 minus 4 is greater or equal to a 0. So this is 3 into negative 4 greater or equal to 0. What are we getting? We are getting negative 12 greater or equal to 0. Is it greater? No. So even this region is not satisfying, is not having digits that are satisfying our inequality. So let us now get the region C, numbers that are beyond a 4. So here we are going to have get what are we going to get here? We are going to have 5. So 5 plus 3 into 5 minus 4 is greater or equal to 0. So this is 8 into brackets. What is this one? This is 4 minus 5 minus 4. This is 1 greater or equal to 0. So we have 8 is greater than 0. Right, this one is going to be applicable. So this one is going, our values of x are going to be greater, this is less, so they have to be greater than a 4. Okay, now let us look at another example. I hope you are there. Please subscribe and follow and share. Okay, let us look at another one. So this one is saying this is x squared, example 3. So we have x squared minus 3x minus 4 is less than 0. Okay, now this one's already set because it is less than 0. So our sum is negative 3, then our product is negative 4. So two numbers, when you multiply them, they give you negative 4, and when you add them, they are giving you negative 3. So automatically that's a 1 and a 4. But which one? So 4 must be negative and 1 must be a positive, such that when you add negative 4 to a 1, you get negative 3. So this is x squared minus x, this is plus x, this one it's going to be minus 4x minus 4 is less or equal to 0. Then what are we going to have here? We are going to have x squared plus x, then minus 4x minus 4 less or equal to 0. Then this is x into x plus 1, then minus what is common here, 4 into x plus a 1, then less than a 0. So why is this one plus? Because when you open the bracket, this one will affect the bracket. So when we open it, it has to come back to a negative. Therefore this is x minus a 4 with x plus a 1 is less than a 0. So our boundary lines, our boundary points, we have negative 4 and a what? A 1. So if x minus 4 is equal to 0, then x is equal to 4, and if x plus 1 is equal to 0, so x is equal to what? To 1. So those are our boundary points. So let us draw them and test. So we are having a 1 here and also a 4. So this is a number line. Here it is continuing to negative infinity, then this one is negative positive infinity, sorry. So this is a 1. We have point A, B and C. So we are testing if we get a number beyond a 1. So let us assume it is negative 2. So if it's negative 2, so negative 2 minus a 4 into negative 2 plus a 1 will be less than 0. What are you getting here? Negative 6 into what is this one? Negative 1 less than 0. So this is positive 6. Is it less than 0? No. So this one is off. Then let us get that one beyond 1, that is between 1 and 4. Let us take a 0. So here we are going to have 0 minus 4 into 0 plus 1. So negative 4 times 1, is it less than a 0? So this one is not there. Sorry, this one is not less than 0. So what is this? Negative 5 is less than 0, right? So this region is going to satisfy. This region here is going to satisfy. So here less than this. Now let us look at the number which is so when you look at this one, any number which is here, the numbers that are greater than 1. So we have x is greater than, so all those values that are greater than 1, they are going to give us the solution. Now let us look at those ones that are beyond a 4. So let us pick a 5. Then to be what are we having? We are having 5 minus a 4 into 5 plus 1, will it be less than a 0? So this is in 1 into 6 less than a 0. So 6 is less than a 0. So this one is not applicable. So the values of x are x is greater than a what? A 1. Alright, so let us look at one more example, and then we see what next. So this one is saying 2y squared then plus 3 is less or equal to a 5. So 5 is inclusive, so to make it quadratic, it is going to be 2y squared plus 3. Sorry, this is 3y. This is 3y. 3y then minus 5 is less or equal to a 0. So our sum is a 3, our product is a 5. So two numbers, when you multiply them, they are giving you but now before getting this one, here we have a coefficient of 2. So this coefficient of 2 is going to be multiplied by a constant. So our sum is going to remain a 3, then our product is going to become a 10, negative 10. So two numbers, when you multiply them, they are giving you negative 10. When you add them, they are giving you 3. So that is 5 and negative 2. So this is going to be 2y squared plus 5y minus 2y then minus 5 is less or equal to. Now those answers who do not know how to solve quadratic equations, please just follow UG revision UG to get that lesson about quadratics. Then you come here to then when you come here, it will be fit to solve the quadratic equations. So here what I'm having, we have 2y squared then plus 5y. This one we are pairing, then 2y minus 5 is less or equal to 0. So we factorize, sorry, then what is common here, it is a y. So y out will remain with the 2y plus a 5, then minus what is common here, what is common is a 1, so minus then 1 out, which is going to be 2y, then this one is going to change to positive, then 5, so less or equal to 0. So y is going to go with the this negative 1, so minus a 1 then into 2y plus a 5 less or equal to a 0. So our boundary lines, so if y minus 1 is equal to 0, so y is going to be a 1, and y and 2y plus 5 is equal to 0, so 2y is equal to 5 by 2, then by 2, so y is going to be a 5 out of 2. Okay, so on our number line, we are having our boundary points. This is 1, then 5 out of 2, this is same as 2 and a half, or this is 2, this is 2.5, so we are having 2.5. Then this is a number line, so this way it is negative infinity and this way it is positive infinity. Now we have regions A, B and C. We are testing them. Suppose we get a number greater than this, let us take negative 2 from this region here and we fill in here. So if y is negative 2, so negative 2 minus 1 into, then this is negative 4 plus 5, is it less or equal to 0? So here it is inclusive, even this one is also inclusive. Now this is negative 3 then into negative into a 1, this is going to be a 1, it's less or equal to 0. So negative 3 is less than a 0, it's right. So we are going to have the first one going like this one on a number line, whereby the first inequality is now going to be x is all numbers that are less than this, so less than a 1. Then let us test this one when it is greater than 2.5. Let us choose a 3 here, then it will be when we substitute in here, so it will be 3 minus 1 into 6 plus 5. Is it less than 0? What are we having? 3 minus 1, this is going to be this one's going to be a 2, then this is 11, then less than 0, so this is going to be 22, less than 0, no. So this point, this we shall not get. Let us now get in the middle. The middle is going to be a 0. So let us choose a 0 from the middle. So now it will be, sorry, let me rub it clearly. So from here we shall get 0 minus 1 into 0 plus 5, is it less or equal to 0? So this is negative 1 into a 5 less than 0, so negative 5 is less than 0, right? So even here it's going to be working. So here it's going to be now it's going to be x is less or equal to 2.5. So we have this x is less than 1, and also x is less than or equal to 1, and also x less or equal to 2.5. So please, my dear learner, try out the following. Try out these numbers. 1, 2x squared plus 3x minus 5 is greater than 0. Then number 2, you try out 2x squared plus 5x minus 12 is greater or equal to 0. Then number 3, 2x squared is greater than x plus a 6. So I have been a good learner. I urge you to do to click on the link below such that you get the quizzes and the notes. We meet in the next lesson, where we shall be looking at linear inequalities with the two unknowns. So in the next lesson, I urge you to be with your graph book.